This is the robot for a person's desk. This was about a 6-month effort. I started in January 2015 and I'm still working on it. Here it is July, but it's mostly there. And what we've got here, basically the purpose of this robot is to kind of a cube mate at a person's desk. It will know when you're at your desk and when you're not, and it will also, if you leave your badge in your badge reader at your desk, it will warn you not to leave your desk without your badge. It can do other things too, like maybe remind you to lock your computer or do your time card, and it does a couple more things which I'll demonstrate. One thing that it does is, after a period of time, I think about 20 minutes, it will remind you that you've been sitting there for a long time and you should get up and get some exercise. And it also has ability to detect a very high temperature. So to turn on the robot, it basically runs off USB power, 5 volts. So we're going to plug in 2 parts to it. This is the Raspberry Pi power, and this one is the servo motor power. And this is coming off from a Amazon Basics high-powered USB. So the robot is now plugged in. You can see 2 green LEDs down at the bottom which indicate power for the Pi and power for the servo. You can see the Raspberry Pi red and green LEDs down there clicking away. This is a powered speaker from Amazon, and you can see the Omron temperature sensor is in the ear. There's an LED in the mouth, and we have 4 LEDs here on the Pi. Once the robot comes up and the sensor begins looking for temperatures, you'll see that these LEDs are indicating whether it thinks it's found a person or not. Hello. And the robot just said hello because you can see a lot of green LEDs there. So it's detecting the temperature of me. There's a yellow indication, which is kind of a weak indication of a person, and the 2 green in the center means it's likely to be a person right in front of it. Now, this robot also has a servo motor, which you can see right there, which currently has a little bit of a jitter problem. But if I move over here, you can see the LEDs kind of follow me, and as it turns its head towards me, it's able to detect where the heat source is if it doesn't move too fast, which it just did. So I moved too fast, but it's locking back onto me, and it found me. And if I move this way a little slowly, it's turning its head and following. So it just lost lock on me, and now it's trying to get that back, and it does. So that's part of what this little robot does, and it's also got some additional features. So you can hear it saying hello and goodbye as it tries to find me and keep locked on to me. So what I've done is there's another LED here in the upper left corner by the Raspberry Pi leaf. That LED indicates whether or not your badge is plugged into a badge reader. So this is a badge reader, a USB badge reader, and so it's got a USB cable coming out that you plug into your work computer. And what I've done is modified it, as you can see, with an additional cable, because there is an LED inside here that indicates when your badge is plugged in or not. This is basically a photocell running into a transistor circuit inside here, which will turn this LED on when it senses your badge It also goes to a GPIO input in the robot. So I'm going to plug my badge in, and you can see the pink LED turned on, and so my badge is recognized. And now when I leave,
stop, don't forget your badge. Goodbye.
The robot says stop, don't forget your badge, in addition to goodbye. And then when I take my badge out, the LED goes off. So it will warn you if you leave your desk without your badge. Yeah. One more feature of this robot is a very interesting thing that I discovered while I was working on it, and that is that it can detect high temperatures. So if you put,
I'm sensing something very hot.
so you can see what happens when there's a fire. The LEDs go red and it warns you that it's sensing something very hot. So you might want to look behind you to see if there's a fire, or it could possibly just be your coffee cup, in which case you should still look behind you to see if there's a fire. Also, it will follow the flame. It will fixate on the flame on the heat source and follow it around. When there is no one around, the robot will just kind of roam, and it will turn its head 180 degrees and try to find a person. After about 5 minutes of that, it will just stop and wait for a temperature measurement that makes it go into yellow or green. So we're going to turn the power off, and if you look in the back, so you can see this basically is an Ethernet cable that I used because it's got handy dandy twisted pair all the way through. This delivers power to the robot, as well as I2C signals for the sensor and the LED. Didn't have enough wires, and I wasn't too eager on running the audio through, so this is the original powered speaker head audio plug. And down here is the battery compartment. So you can see I just used the battery compartment to attach to the servo motor. There is an elastic band in there which kind of adds a little bit of torque to the servo motor, and that helps keep it from jittering. This glass jar obviously is a very inexpensive container. And you can see here the servo motor. You can also see a 1000 microfarad capacitor attached right next to the servo motor. I was really surprised at the kind of current draw those servo motors do when they have to make a movement. It's a really quite a heavy-duty surge of current, and this is a tiny motor. This is one of the smallest ones you can get, micro server. So that's the servo motor, and we'll pull our guts out here. And take a look. First of all, I just have some weight, some nuts and bolts in there in a plastic box, because when that servo motor turns, if it turns quite a ways, it can actually spin this whole thing right around on a smooth surface. So here's the Raspberry Pi on the bottom. The SD card is there. This device here is a USB audio amplifier. I found that the audio port on the Raspberry Pi, which is right there, was really not providing a loud enough signal. So you can see also on the Pi there's the USB ports, the Ethernet port, the display port, the power port, and here are all the GPIOs. So what we have here then is what Adafruit calls their Pi hat. That's the white circuit board there. It's just a breadboard, so you solder parts into the breadboard and hook them up to the GPIOs and hook them up to everything else you want to do. So here's the servo connection going to a couple of GPIOs and separate power source. This device right here is a level shifter. So the servo motor, PWM input, and the Omron temperature sensor I2C signals, which are these two green and yellow signals here, those are all 5 volts, and the Raspberry Pi GPIOs are 3.3 volts. So you need to have this level translation, and not only does it have to translate to level, but it has to be bidirectional for the Omron data port transmit and receive. So this is also from Adafruit. This is a bidirectional level translator. A couple of resistors and some LEDs, and then also I added these 4 tricolor red, green, yellow LEDs and hooked them up to GPIOs so that I could get an idea of what the sensor was seeing. And then there's a little transistor circuit and the pink LED for the badge reader. This is a relay that's actually not in use at this time. So all those wires come through here, and then they come through this makeshift lid here and come out. And so that is